Okay, so on Thursday, we learned about negative exponents, we learned about zero exponents, and we learned that if you multiply two exponents together that have the same base, you add the exponents together. So what we're going to learn about today is what happens if you take an exponent to an exponent. So it's exponentception. It's exponents within exponents. So essentially what happens, let's say that I want to do, let's do it with numbers first, and then we'll throw some variables into it. Let's say I want to do 2 squared, and then I want to take this and raise it to the third power. So I want to do 2 squared to the third power. I know, it's a little scary, right? So that means I'm taking 2 squared times itself 3 times. So before I evaluate this 2 squared part, I'm just going to look at what this to the third power means. So this is the same thing as doing 2 squared times itself how many times? 3 times. So 2 squared times 2 squared times 2 squared, right? So this is going to be the same thing as now I'm multiplying powers with the same base. So same base, what would I do to the exponents? Add, right? This is what we learned last Thursday. If it's the same base, 2, 2, 2, then I add the exponents. So this is going to be 2 to what power? 2 to the 6th. So if you take a power and raise it to another power, what did I really do to these two numbers, the 2 and the 3, to get to 6? So 2 plus 3 is 6? Okay. What 2 and 3, what operation between 2 and 3 makes 6? There we go. That sounds better. So if I take a power and raise it to another power, I multiply the exponents. Okay? So that's the rule. So a power raised to another power, a power raised to another power multiplies the exponent. All right? There's one more rule with this that I need to go over with you guys, and then we'll take a look at a few examples here. So let's say if we have more than one thing in there, and this is where I'm going to throw in some variables. So let's say I have something like 3x to the third, and I'm going to do this whole thing cubed. All right. So this is the same thing as doing what's inside the x, or what's inside the parentheses. I'm going to multiply it by itself how many times? 3, right? So I'm going to do 3x to the third times 3x to the third times 3x to the third, right? Yeah. So I'm going to do 3 times 3 times 3, which is what? Okay, so I'm going to get 27. And then I'm going to get x to what power? 9. X to the 9th. Now what a lot of students will tend to do when they see this part, they'll remember to do x to the 9th, they'll remember to do 3 times 3, and they'll get x to the 9th. But a lot of students will write this as 3x to the 9th, and they'll forget that they need to change the x part. So this is the correct answer, 27x to the 9th. This is the incorrect answer. So what's happening here is this third is kind of distributing itself to both things inside. So like this becomes, I'm just going to like write it down here, this becomes 3 to the third, x to the 9th. So guess what 3 to the third is? 27. And then x to the third is x to the 9th. So like this should be, this is the correct answer. 27 x to the 9th is the correct answer. This is not the correct answer. This is wrong. No, this, because I don't have another thing here. Because I don't have like a second thing here. This I have 2 things. I have a number and I have something that's a base. This I just have something that's a base. If I had another thing here, like say times 4, then it would change it. Okay? It's because I have two things that I have to kind of distribute that exponent. Does that make any sense? So that's the second kind of rule that we're learning is the exponent, and I'm going to put this in quotations because it's not the correct mathematical term, but it's the closest mathematical term to use, distributes. The exponent distributes. So you distribute the exponent to everything inside. So the 3 gets the exponent, and the x to the third gets the exponent. Okay? Kind of, sort of? All right. Let's take a look at how we would use this property in one example. Well, actually, let's do 2 examples. Let's do one with me, and then we'll do one on your own. And then we'll take a look at your assignment. So let's mash this up with what we learned on Thursday. Let's do, let's do 2. Let's see. Nathan, what variable are you feeling today?
Not a good one.
Right. I need something more specific than that, please.
Oh my god.
I just need like a letter, a box, a wingdings character, a drawing I can put down.
A jelly donut.
Just something from you, dude. Y. Okay. Okay, let's do 2y to the third times. Okay, we'll do 2y to the third times 3xy squared times, in parentheses, 2xy squared, close parentheses, to the third power. Nope, yep, get it out of your system. If you want to cry, the fetal position is okay. Get it all out of your system right now. Okay, yep, nope.
Oh, you didn't fall off the chair?
No, she's taking my advice literally and not comically, how it was meant to be. Okay, so no, that's what the fetal position means, Nathan.
What?
That's what the fetal position means, Nathan.
The fetal position?
Don't worry about it. Okay, Jessica, get back in your chair. Thank you. All right. So let's do this one piece at a time. Let's look at the new piece over here. So I'm going to take this exponent, I'm going to distribute it to everything inside. All right? So first I'm going to find out what 2 to the third is. So 2 to the third is 2 times 2 times 2, which is 8. And then x, this is, if there's no exponent, what exponent's really there?
1.
So this is going to be x to the 1 times 3 power. 3, right? 1 times 3 is 3. And then this is going to be y to the 2 times 3 power, which is 6. Then over here, I'm just going to drop these down as they were. 3xy to the second, and then this is 2y to the third. Because it's 2 times 2 times 2. Because it got the third power distributed to it, Nathan. Now,
I can't do it.
you can. From this step on, it's exactly what we were doing on Thursday and Friday of last week. So 2 times 3 times 8. So 2 times 3 is 6. 6 times 8 is 48, because 6 and 8 went on a date.
And came back with a lot of meat.
Okay. And then y to the third. Okay. Y to the third. Y to the second. Y to the sixth. If you're multiplying, you add the exponents. 3 plus 2 plus 6. So y to the 11th. And then x. If there's no exponent, it's got an exponent of what? Okay, guys, listen. If there's no exponent, it's got an exponent of what?
1.
X times x to the third is x to the... So then this is the final answer.
48
Y to the 11th, x to the 4th. And if you were to flip those two, have x to the 4th be first, it wouldn't be incorrect.
You know what's really sketchy?
Carnies?
Glare.
True.
The glare on the whiteboard makes you see stuff that was erased.
Oh, okay.
That's glaring.
Okay, so I'm going to have you guys try one on your own here. Okay, so copy this down into your notes. Give it a try. Let's do 3a to the 4th times 2ab to the 3rd times, in parentheses, 3a squared b all to the 2nd power. Okay, your number part's right. This should be, yep. And then, so you're going to do 4, 5, 4. So now you're just adding everyone across. So you're only multiplying when you're doing powers or powers. And you're going to add when you go across. It's not 36, because 3 squared is 6. So your variable part is right.
Correct.
So by 3 meters per part again. 3 squared. Okay, so first, 3 squared. No, 3 times 3.
Oh, yeah.
9. So put the 9 underneath the part. And then into the 3 times 2, which is.
Oh.
So you're taking, when you're doing a power to power, you multiply the power. And then b, which is b to the 1st. And 1 plus 2 is going to be b to the 2nd. And now you drop everything else down and do exactly like you did on first. 3 squared is 6. And your variable part is right. Oh, that's from calculus. It's a three-dimensional representation of no, it's put off on one board.
It does look pretty.
What is that?
So one thing that people work, it's last week's quiz for my calculus students. They had to make a three-dimensional representation of volume. This is their quiz.
Yeah, when you're like looking at it like that, it looks like a 3D drawing.
Okay. All right, so not too bad, yeah?
Very terrible.
Couple things here. Make sure that you know the difference between square root and times 2. Not pointing at any names, but that came up more than once. Second,
It's 9:04. Don't do it.
I'm still going to hand it out.
No.
Yeah.
Can you give me the answer key?
No. I made sure to separate the answer key to set. So what happens is when I print them out, I send them to the printer in the office. And when I do that, I'll send a copy of the assignment and then a copy of the answer key. And then I'll send a copy of 60 of the assignments, which is how many I need of the assignment plus 10 extra, because Algebra 1 students will be losing their assignments. And then so what happens is usually I'll find the answer key, set it aside, and then on Friday, because I was so frazzled, I didn't.
And then you ended up
So the answer key is always the second one down in the pile.
So
So,
he sends copy of the assignment, copy the answer key, 60 copies.
and then 60 copies of the assignment, yeah. All right, so I'm going to give you time to work on this tomorrow in class. So
Yay.
hold on. It's not going to be due. It's not going to be due until, let's say. No, let's say. Yeah, so okay, we'll say beginning class on Wednesday, but I'm not going to give you all of class tomorrow to work on this.
What are we doing tomorrow then?
Let's go through
Are you giving us another assignment tomorrow?
possibly.
You just gave us this.
Okay, well possibly. Let's go through the first part of this right now, though. Let's go through the first part of this right now. Let's go through the first part of this right now. Okay, so number one. Okay, number one. We're going to take the exponent and we're going to distribute it to everything inside. Alright? So if it's a number, we're going to evaluate the number to that power. And then if it's something that isn't a number, then we're just going to multiply the exponents. So this is going to become x to the whatever 2 times 4 is. 8. Great. And then we're going to have to actually find out what, so times, we have to find out what 2 to the 4th is. So 2 times 2, which is 4 times 2 times 2.
16.
Okay. So times 16. And then this is going to be x to the whatever 3 times 4 is. And then this becomes y to the whatever 3 times 12 is. Alright, now we have to combine all these variables. So this is 1 times 16, which is great. X to the 8th times x to the 12th, which is x to the 20th. And then y to the 12th. So this is the final answer. Okay? Alright. We're going to continue these tomorrow. Have a great day. I'll try to learn math. Hello, how are you?
Yeah, I'm doing alright. How about you?
I'm not. Hello.
How many more weeks of this school do we have?
Well, there's 40 weeks in the school year. We're on week number 23 right now.
That's still too long for me.
Okay.
He went home.
Did we already do that question?
Oh, yeah, we did. You should have, wait. This is the one you should have. I don't know why the other one's up there.